Thank you for joining our webinar today on advancing hydrographic surveying with centimeter accuracy in real time. So to start, myself and Nick Smart will be presenting to you today. And just to introduce myself, my name's Keely Shea. I hold a Bachelor of Science in Geomatics and Geodesy Engineering from the University of New Brunswick in Canada. And I work for Trimble Positioning Services as a product manager. And I'm specifically working on the products Trimble VRS Now, IBSS, and Centerpoint RTX Marine.
And I'll extend my welcome to everyone tuning in. Good morning, good afternoon, and good evening. My name's Nick Smart. I work for Trimble Applanix, and I'm a hydrographic surveyor. I perhaps took the typical route of the IHO Cat A course in Plymouth many years ago. Did my stint offshore, working around the world on a variety of different applications, and joined the Trimble Applanix Marine team back in 2020 as a pre-sales support engineer, supporting our network of OEMs, resellers, and of course the end users with their applications relating to POSMV.
For today's topics, Nick and I will be going through Trimble Positioning Services and Trimble Applanix and giving a brief overview, as well as going into the specific products, Centerpoint RTX Marine, and then the Trimble Applanix POSMV system. And then as well as how their seamless integration from an application and a workflow standpoint as well. And then we'll be finishing it off with a few practical tips, some acquired data, and then we'll be finishing it off with questions and answers. If anyone has any questions throughout the presentation, please feel free to add them into the Q&A box as we're going through, or you can save them to the end for the questions and answering. The question and answering period. So to start out, a brief introduction on Trimble Positioning Services and Trimble Applanix. So Trimble Positioning Services has a longstanding legacy of providing market-leading technology in relation to GNSS corrections, providing global coverage and expert support around the clock for several different correction types, from IBSS, so Internet Base Station Service, to VRS Now, to Trimble RTX. It's been a decade-long journey that has led us to where we are today, and specifically supplying a precise point positioning technique for marine applications. So to go through just a timeline of Trimble and the legacy of its standpoint in positioning. In 1994, Trimble introduced the first RTK system, and then in 1998 introduced Trimble VRS Now. If we jump to 2011, Trimble introduced our RTX service, or PPP service, which was GNSS precise positioning without a base station. In 2014, we provided BIDU 2 and Galileo support. And then in 2015, regional ionospheric and tropospheric models were supported in Trimble FAST regions. Now, if we jump down to 2020, BIDU 3 support was supported with broadcast ephemeris validation. And then in 2022, we worked with graduates from the University of New Brunswick and Amundsen Science to get validation testing in the Northern Arctic in Canada and Greenland waters. And then in 2022, Centerpoint RTX Marine was introduced and supported on all Trimble Marine receivers. In 2023, we had beta testing completed with the Trimble MPS 566 by some of our early adoption customers. And then by the end of 2023, we had some major adoption by different dredge contractors.
So to give you a brief overview of Trimble Applanix. So for the last 30 years and more, Applanix have led the way in the GNSS-aided inertial navigation space. We provide solutions across four industries, air, land, and marine, but all with the common goal of providing a precise and robust measurement of your vehicle position and orientation for mobile mapping applications, be that LiDAR or multi-beam. POSMV customers, Applanix customers, include big dredging firms, as Keely mentioned, the likes of Van Orge, Yander Knowles, the big government organizations like NOAA in the US, military organizations, the various navies spread across the world, and of course, recognizable names in the automotive industry and beyond. The POS-MV and its associated post-processing software, POS-PAC MMS, are the market leader in position and orientation solutions for the hydrographic industry that we're all here to listen about today. Applications are wide-ranging, from small coastal survey vessels like the little 8-meter yellow catamaran you see in the top left there, that belongs to SCP Hydrographic, based here in the UK, to more innovative solutions like Ultrabeam's amphibious Argonaut vehicle there, the tracked vehicle you see in the middle. But whatever the platform, whatever the purpose, there's this common goal of collecting robust navigation data, whether it's under and around bridges like the Tower Bridge in London you see in the bottom left there. That was collected with an integrated Norbit system with a POS-MV integrated inside the sonar head. Or far offshore mapping, wind farms, inter-array cables. Whatever the use case, our team, based out of Toronto in Canada, and its globally distributed domain experts, OEMs, resellers, are there to help you, the end user, potential customers, select the right product for your application and support you through its life cycle. So moving on to the timeline of Trimble Applanix. Let's say for over 30 years now, we've been leading the way in GNSS-aided and ocean navigation. The first POS was delivered back in 1994. Market dominance was established just a few years later. And as we skip through the decades, I have to mention the acquisition by Trimble in the early 2000s, the introduction of our AP product line for our integrators, for our OEMs, and POS-PAC MMS, giving you the option to post-process your data. And then up to the current day, where we stand as continuing to lead the market in this space and leveraging all of these core technologies that Trimble is so uniquely placed to serve. I'll pass it back to you, Keely.
Okay, so now to introduce to our product specifically, Centerpoint RTX Marine and Applanix POS-MV. So to start out, what is Centerpoint RTX and what is this product? So it's a precise point positioning technology that uses Trimble's global network of reference stations to accurately generate state-space representation models of the ionosphere and troposphere, as well as accurate GNSS satellite ephemeris data to mitigate clock and orbital biases. So this diagram here kind of walks you through each component that I'm going to talk about. So our global reference station network communicates with the RTX server software where global GNSS satellite data is synchronized and all those pesky orbital biases are calculated, as well as our clock code and phase biases are estimated, and then global and regional models are generated for the signal code and carrier phase biases of the ionosphere and the troposphere. So we then send these corrections to the user via two different delivery methods, one being N-trip or internet, or by uploading all of our correction data to a series of geostationary satellites that are located all around the world. And then it's broadcasted from those satellites via L-band back to users on the ground with Trimble receivers. Trimble RTX also uses a separate global network of integrity monitoring reference stations, so a secondary set, to verify the corrections both pre and post broadcast. This ensures we have further service dependability. And then we also have multiple uplink stations to add again further redundancy for the product and service. So if we go through some of the key benefits to this service, especially when it comes to the marine industry, it's accurate, untethered, reliable, efficient, and as well as cost efficient. So to start out with accurate, it's 2 centimeters and 2 centimeter horizontal and 3 to 5 centimeter vertical RMS. I'll go into that a little bit more in the next slide. It's delivered in real time via satellite or internet and trip. It ensures maximum uptime, redundancy, and monitoring, as I just mentioned. saving time and money, and it works everywhere. It is a full constellation solution supporting GPS, GLONASS, Galileo, Baidu 3, and QZSS, as well as it features AES encryption and NAV message authentication for anti-spoofing. So when we think of anti-encryption and anti-spoofing, these two tools help to prevent any spoofing, and it makes it really hard for anyone to replicate the RTX stream, since it's significantly easier to target specific common unprotected L1 signals rather than full constellation NES encrypted and NAV message authentication streams. So to go into the key specifications, when I mentioned accuracy, so we spec 2 centimeter RMS horizontal and then 3 to 5 centimeter RMS vertical. This is dependent upon location of use as well as receiver type. So that 3 centimeter value is for vertical is on Trimble ProPoint receivers. So think the BD992 that's in the POSMV system. And then 5 centimeters on older receivers, and again, location dependent, but I'll go into that a little bit further down. Our convergence time for Trimble RTX fast regions or our formed beam regions is under 1 minute, and then worldwide on ProPoint receivers is under 3, and legacy receivers 15 minutes. So basically, once you start your boat and get to where you're going, you'll have converged on your solution. For delivery, as I mentioned before, we have 2 ways of delivery, as well as using both of these adds added redundancy, and those are via satellite and via internet. The datum that you get when you receive your RTX correction is ITRF 2020. In POSMV, you're capable, when you receive the correction, it can transform it into ITRF 2000, and then within POSMV, you're able to select your local datums that are available here. Our next slide, specifically speaking to different GNSS correction methods and what the expectation should be around accuracy and those methods. So this graph here is a scatter plot showing the latitude error and longitude error of different correction types, specifically traditional RTK, VRS, traditional RTK over short baseline, over long baseline, VRS, and then Trimble Centerpoint RTX. So when you look at this graph, what you can see is that in the center of it, RTK over a very short baseline of 124 meters is the most accurate. But as you expand that baseline and get further and further away from your base or from the nearest VRS reference station, you can see that all 3 solutions are performing relatively at the same precision level and closing in on a very, very similar accuracy. So this is going to bring me into the coverage of Centerpoint RTX Marine. So it is global coverage, and we offer it's satellite delivered via L-band over 6 different beams here, which are shown, including 2 form beams that provide tropospheric and ionospheric modeling in North America and Europe. Next, we have a regional coverage. So our regional L-band coverage is satellite delivered up to 200 kilometers from the coastline and this is where we spec our 2 centimeter and 3 to 5 centimeter RMS accuracy. So again, 3 centimeters dependent upon receiver type, 3 centimeter to 5 centimeters dependent upon receiver type, as well as staying within the 200-kilometer distance of our RTX reference stations. But again, it's delivered worldwide, and you can use RTX globally via those L-band beams, as well as via worldwide IP coverage.
So this leads nicely on into why is our real-time data important? Why is accuracy important? And there's probably a lot of hydrographic surveyors on the call, and you may already know all these things. And as I said, there's so many services that are so widely available that perhaps it's taken for granted that you turn your system on and all of a sudden you've got centimeter level data and you don't give it a second thought. So it's worth just revisiting some of these points as to what this means for the general user and the decisions they're able to make as because of the accuracy they're able to achieve. So the big one for me is allowing that informed, accurate, data-driven decisions to be made. This becomes ever more important as platforms become more remote. The advent of remotely operated vehicles, whether it's ASVs, USVs, has boomed recently, and sending something off without a crew on board to achieve precise and accurate data is a must to take advantage of the efficiency you gain by running that sort of platform. Reliable real-time data with centimetric level accuracy removes the need for post-processing and the extra costs and people associated with that. And of course, a precise and accurate real-time solution can provide you with the confidence with respect to coverage when you're mowing the lawn, collecting your seabed bathymetry data, to feature detection, whether it's UXO surveys or identifying boulders on potential cable routes. Tying back to my first point of being able to make these informed, accurate, data-driven decisions. And of course, all of this allows you to act quickly. Time is money on a vessel quite often, and being able to make these informed decisions is a big part of what we're doing, as well as data collection. So to tie this into why RTX is so good for this, if we can appreciate the why, then we can understand why RTX fits into this solution. Because RTX delivers this near RTK accuracy, as Keely had shown in one of the previous accuracy slides, and with market-leading convergence times, you get there quickly. You can deliver this informed insight with confidence. The workflow is efficient. By combining the Trimble and Applanix expertise, we've integrated the correction service into POSMV through a smooth workflow, offering flexible delivery methods, as we say, via L-band, via NTRIP, manual beam selection, subscription activations over the air and via a passcode, and associated subscription metrics, so you can see when your renewal date is coming up. You build efficiency. You're reducing hardware. We're seeing a shift of classic base rover VRS users moving to RTX in coastal regions. If you can remove the hardware, the extra cost and maintenance associated with that, the security issues of having a base station on the shore, and replace it with a fully untethered solution, then you're driving that efficiency of your operation. And all of this integration of Centrepoint RTX into POSMV is dependable. It's assured with integrity monitoring, with advanced security features that Keely mentioned earlier that address anti-jamming and anti-spoofing. And of course, it's all supported by a worldwide network of domain experts that can help you when you're struggling, that keep this service running. On to the next slide. And I guess we've got a pretty clear indication of what applications are on the call, and seabed mapping is a big one. And I think we can probably relate most of these on the slide to that. But the point of this slide is to demonstrate that RTX is offered in a series of products that suit your need. So as we've alluded to, there's a coastal, a regional, and a global subscription level that you can purchase. And coastal, that's geofence to 20 kilometers, might suit your ports and harbour survey, your coastal dredging, flood protection, coastal mapping and monitoring. These things that don't require you to go offshore, your small vessel work, where you maybe want to reduce that typical base rover setup and cost associated with it. Then we can move on to our regional subscriptions, this 200-kilometer section that, particularly in Europe and specifically here in the UK, a lot of that work is carried out in that sort of region with marine infrastructure, so our wind farms, associated inter-array cables, pipeline inspections, and as we say, our general seabed mapping that's associated with all of those. And then for true global mobility, you have your global offshore subscription. This will allow you to use RTX with your POSMV anywhere in the world, no matter how far offshore you are, and achieve that centrometric level of data. On to the next slide, please. So to talk a bit more about Applanix POSMV, not everyone here will know what a POSMV does and what it means. So on the box, POSNV stands for Positioning and Orientation System for Marine Vessels. And all of these applications that we've already mentioned aren't possible without a position and orientation system. It's generally the heart of the vessel. It's providing information not only to the surveyors for their georeferencing of their sensors, but for the helmsman, for clients, and anyone else that might be interested. POSNV is a tightly coupled GNSS-aided inertial navigation system. It harnesses technology that we've already mentioned with Trimble, ProPoint, and IonoGuard. And we have our Infusion Plus algorithms that combine all of this information together to create a navigation solution. You see on the left there a typical Ocean Master setup with dual antennas, an IMU in the yellow box, and the orange box, the PCS, the heart of the system that pulls all of this data together, that creates your integrated measurement of position and orientation and all of the associated metrics that come with that. Next slide. And so some of the specifications, the general model range of the POSNV runs from the entry level, the budget version, the Surfmaster, through to the Wavemaster and the Ocean Master. Typically, how we define the system you might need is often based on the size of vessel you're installing it on. Anything with a big lever arm between, for example, your IMU and your GNSS antennas will require a high-grade IMU to account for that angular accuracy that is typically exacerbated over long lever arms. But it's not just tied to that. There's a lot more that comes into it. A lot of it depends on the environment you're working in. The thing that separates these model lines is the grade of IMU. You can see Centrepoint RTX will provide you with the same positioning solution irrespective of the grade, but where the difference come in is in the application. And on this following slide, we can see an example. If we can move on to the next one, please. There's a case here from one of our OEMs, Teledyne, with their new CBAT 251, and this is in Thailand. And obviously, it's an inland river, but RTX here was used in real time. And you can see the sort of environment they're dealing with. There's bridges, there's high-rise buildings, a general urban area. So you'd expect lots of GNSS interference. Here, this is an application where having an Ocean Master really trumps the others because you maintain that inertial accuracy when you're struggling in a difficult GNSS environment. And that's what POSNV does. It's combining the good points of GNSS, the good points of inertial, and getting rid of all the bad bits associated with those to produce a robust navigation solution. On to the next slide. So some of the key benefits of using a POSNV and some more great data examples on the left there. As I said before, robust georeferencing in harsh GNSS environments is what a POSNV does, ensuring reliability and maximum uptime. In Fusion Plus, these latest generation algorithms tightly integrate the GNSS signal, the Centrepoint RTX, tracking all available constellations and frequencies to aid in this robustness of solution. We employ continuous sensor monitoring for optimum performance. You don't need to send your POSNV back every year. POSNV is self-governing in its health. It will alert you through POSView if something is not quite right with the system, whether that's installation related or hardware related. Because of these latest generation algorithms, we're able to near instantaneously reacquire RTK level accuracy or RTX level accuracy following a GNSS outage, whether you've gone under a bridge, through a tunnel, or under a gantry crane, whatever that interruption might be. Because of this tight integration of all this aiding sensor data, POSNV is able to reacquire its accuracy within seconds of GNSS reception reappearing. And there's flexibility built into the system, of course. Whether you're integrating corrections from an RTK solution, Centrepoint RTX, inputting, outputting to multiple sensors, POSNV is flexible in how you apply. And of course, we have our supporting post-processing software, POSPAC 9, with the post-process version of RTX, PPRTX 2.0. And we'll maybe jump into that a little bit later on. On to the next slide. So how does all this tie together? What we're really here to talk about today, and that is this seamless integration. As many of you know, Trimble is a global company with a wealth of talent and expertise. And something we're very good at is bringing together cutting-edge technology to serve our customers, enabling them to acquire, process, and interpret data. And the combination of Centrepoint RTX and POS-MV is a perfect example of the kind of integrated solutions that Trimble can bring to the market. Can you skip back a slide, please, Kelly? I just want to speak to these images that we have here. Again, from the T51 in this 800 kilohertz mode with an integrated POS-MV. Yeah, I had to put these in because the tetrapods on the seabed there, the shipwreck, it just shows where we are in the industry these days with all of this combined information and the sort of images we can acquire. So I couldn't not include those. So yeah, please go back to the next slide. So to add some more detail to the seamless integration, we've obviously covered the decades of experience the different organizations within Trimble has, the technical advancements, the merits of Centrepoint RTX and POS-MV, but where the value sits and where you, the end user, people on the call, gain the most is how seamlessly all of this combines into a single product and how you're benefiting from something that only Trimble can do. So this diagram here, from left to right, represents the basic POS-MV data flow. We have a series of inputs, GNSS data, our accelerations, velocities, angular rates from the INS, and of course, a Centrepoint RTX correction service. These enter a centralized filter in the middle there to create a navigation solution and its associated outputs and metrics. To make this work, Centrepoint RTX needs to be easy to use. So it's configured through our GUI, through POSView, the known and well-loved ancillary bit of software to control your POS-MV. You can choose the delivery method, N-trip or L-band. As I say, you can specify beams, activate subscriptions, view subscription status. The UI offers simplicity, an easy way to integrate the service into your POS-MV to create this seamlessness. We don't want this to be difficult for you. You want to turn your system on and achieve centimeter level data without really having to think about it. Trimble ProPoint in the middle there, we've alluded it to a few times already. This is the precise GNSS position engine that was designed from the ground up with sensor fusion and inertial aiding in mind. That's what Applanix does. It tightly integrates the RTX corrections along with all available constellations and frequencies. It employs advanced filtering and modeling techniques to provide this robust positioning solution. And POS-MV and these Infusion Plus algorithms that I've already mentioned leverage all of this technology to build on the resilience, the reliability, and the accuracy that POS-MV is already known for. You can achieve real-time centrometric data globally, giving you the confidence anywhere in water to trust your position. To the next slide. So to round up this section, the combination of Centrepoint RTX and POS-MV represents a full Trimble solution, meaning a single source of hardware, software, and correction services with seamless compatibility and integration, all with this goal of providing robust and precise positioning and orientation, driven by unrivaled expertise and round-the-clock support, allowing you to survey from surface to seafloor with confidence. So as we move on to some practical tips and some real-world success stories, none of this means anything without you, the users, benefiting from it and sharing your experiences with us. So the first point to consider is how you might set up your vessel in the best way to get the most out of RTX. Now, there's an image here from one of our POS-MV customers in the UK, A2C, that a year or two ago did a full dimensional control survey on their vessel that was chartered for that particular period. And you might be able to see the little surveyor standing with his tripod, employing some best dimensional control practices. The real broad takeaway: to receive this RTX signal over L-band and to ensure good GNSS performance, your antennas need a clear sky view. I think that's a given. They need to be free from interference. There's a lot of things on vessel these days, from Starlink to other SATCOMs, Iridium sources. Trimble has a solution to combat all of these things, but you've got to have the right thing for your application. So important to consider where your antennas are placed and what they're next to. They need to be free from interference. They need to be stable. You don't need your antenna wobbling around on a pole, and they certainly don't need to be removed in respect to each other. But the big underlying thing that really guarantees performance, you want those RTX corrections to mean something in your POS-MV and in your resulting survey data. And what underpins that is dimensional control. On the big vessels with big lever arms, having a precise dimensional control survey to define your offsets is really, really key to achieve the best performance out of your system. I can talk about this all day. So if you want to dive into dimensional control, we have a whole series of guides available to steer you in the right direction, and more than happy to discuss another time. So moving on to the next slide. As we introduced RTX into the marine world, we did a lot of testing. Again, we're fortunate to have a collection of customers that are happy to help us develop these things. And part of the testing process involved really pushing the limits of where RTX and general GNSS works in our high northern latitudes, but as well as some of the more common areas of operation, ranging from the Caspian Sea, more closer to home in Northern Ireland, around to Australia, the North Sea, east coast of the US, basically achieving a good global coverage of test data to ensure that we can put our name against the accuracies that we're stating. And all of this led to this product, this integrated solution that is allowing our customers to achieve their desired accuracy. And as we look at some case examples in the next slide, here we have a global map with just a handful of use cases from current customers around the world. And I'll straight away thank you to aiding me with this webinar and providing these images. I'll reference you as we go. It was much appreciated to put this slide together. So starting off on off the west coast of Ireland here in Europe, there's an example here of an uncertainty grid from an early adopter of RTX and early tester. This was Green Rebel Marine. And this is a classic survey pattern. They're running up and down, mowing the lawn. And you can't quite see, but I promise you the uncertainty is within the 5 to 10 centimeter level in overlapping multi-beam lines. Let's move on to the next example. This was from X-Ocean, one of these remote operators that I alluded to earlier. This is, again, RTX in real time over a wreck in the Irish Sea, providing some great data imagery and quality. And on to the next example. So moving across into the North Sea. This was from A2C. And again, another wreck. The hydrography world sure loves a shipwreck. And but again, it's just underpinning the quality of data that using RTX and the POS&V combination can achieve. And as we move down into wider Europe, this is from one of our dredging contractors on an active job running progress surveys with their POS&V and RTX, again producing some high quality image to make these informed decisions, which are really important in the dredging world, where production is key, and having the speed and the confidence in those progress surveys just aids with that dredging process. And as we move down south into South Africa, and again showing you the range of coverage that RTX had. This is from the Council of Geoscience, based just out of Cape Town, and some really interesting rock formations that they've gathered as part of their geological mapping process off the south coast of Cape Town there. And then as we move across to Thailand, and the case I showed you earlier with Teledyne and their integrated ocean master in this difficult urban environment, but again, RTX underpinning the quality of the data. And that was the last example. So some useful links. Marine support at Applanix is the go-to place for your queries, concerns, inquiries, whether it's relating to RTX, POS&V, both, the combination of, or general troubleshooting, any issues you might be having offshore. Our global team of support professionals will be on hand to help you pretty much any time of the day. We have the Trimble Position Services contact address there if you specifically want to find out more about RTX and perhaps some of the applications outside of POS&V you might have. And those that buy through their resellers and their OEMs will have their go-to guys that they can always reach out to. And so I hope everyone is interested in RTX if they're not using it already. So we have a 30-day free trial available for for anyone who wants to use it for their marine purposes. If you can follow the link there, there's a code 330 that you'll enter as part of the trial process. If you're applying this to your POSMV, you'll be required to enter your serial number of your GNSS board, which you can find in your view statistics through POSView. It will ask for your firmware version. All that data is available. If you need help with defining the right settings for this, just give us a shout on those email addresses and we'll help you get going. But it's pretty straightforward to get you up and going for 30 days and seeing how an RTX service can accelerate your operations. Hopefully, in the last hour or so, you've gained an appreciation, if nothing else, of how RTX works, how a POSMV works, how the two combine to provide you with a robust and accurate navigation solution, and maybe a little bit more flavor on the applications people are using this for, and the accuracies that are achievable, and how all of this has been seamlessly integrated into a product that you can install on your boat and collect this. Some of these stunning data examples that we've seen, and again, thanks to the various people that have contributed to those, it adds so much more to these kind of presentations. So thank you again to everyone for your time. Any questions, comments, then please get in touch, and please take advantage of the 30-day free trial. It's a good amount of time to really put the system to use and put it through its paces to see how it hopefully can improve your workflow.
And with that, we'll end out the webinar. Thanks, everyone.